Today you're going to do a little review on things that you talked about last year, area and perimeter of polygons. And we're going to start off by talking about perimeter, and we can see up here that we're told that perimeter is the linear measure around a figure. Okay, we're trying to figure out what the distance would be to go around a figure. Like if you look at this triangle right here, what is the total distance to go all the way around this triangle? Well, in order to find the perimeter, you simply add the sides. Add the sides. Okay, and so we know that a triangle has 3 sides. Therefore, you should line up 3 numbers to add. A trapezoid, well, that's a quadrilateral. It has 4 sides, and that means you're going to line up 4 sides to add. A parallelogram is also a quadrilateral. It has 4 sides, and so again, when you have a parallelogram, there are going to be 4 numbers, 4 sides that you need to add. A pentagon is a 5-sided polygon, and so you're going to line up 5 numbers or 5 sides to add, and so on. Okay, so however many sides there are on the polygon, that's how many numbers that you're going to have to add together to find the perimeter. Okay, the perimeter is a linear measure, and so you're going to label it with the given units. And so what we're going to do down here, we're looking at our triangle. We need to find the perimeter of this triangle, and we see these 3 values, 128 meters, 197 meters, 163 meters. And to find the perimeter, P, well, I'm going to set that equal to 128 plus 197 plus 163. And when we add those numbers together, the perimeter is going to end up being 488 meters. Okay, again, you label it with the given units because it is a linear measure. Okay, on number 2, we have a 1, 2, 3, 4, 5-sided figure. This is going to be called a pentagon. And they tell us here that each side is equal to 4a minus 7. So we see it's labeled here. This is 4a minus 7, but all of these sides are 4a minus 7, and you can go ahead and label them as such if you would like. All sides here are equal to 4a minus 7. We're trying to figure out what the perimeter is going to be in this example. And I could, like I did over here, write out an addition problem to figure out what the perimeter is going to be. But because I know that all of the sides are the same, to get the perimeter this time, I could take each side measurement, which is 4a minus 7, and I can multiply it by 5 because all 5 sides are the same. Now, to make sure that I'm doing the multiplication correctly, what I'm going to do is make sure that I put the 4a minus 7 in parentheses. There are 5 sides. Each one is 4a minus 7 units long. And what we're going to have to do here is use our distributive property like we used back in algebra. So P is going to be equal to 5 times 4a plus 5 times our negative 7. And so when we evaluate now, this is going to give us a perimeter of 20a, and then 5 times negative 7 is negative 35. So we get a perimeter of 20a minus 35. Okay, and so again, just to review, in order to find the perimeter, all you have to do is add the sides. Area is a square measure of a figure. When we're finding the area, we're trying to figure out how much space is inside of that figure. And in order to do that, you need to multiply the dimensions. You need to know what the base and the height are going to be. Okay? We're told here that the height of the figure must be perpendicular to the base. So that means that they form a right angle in order to get an accurate measurement. Okay, and so we have a triangle under here. We see that the measurements, the lengths are 7 centimeters and 2 8/10 centimeters. And I need to figure out how much space is inside of this figure. Okay, and what I can do, I can demonstrate with a piece of graph paper here. I can just go ahead and draw any rectangle. I'll go ahead and draw a rectangle that looks like this. And if I look at the dimensions here, well, at the bottom, the base, I have 1, 2, 3, 4, 5, 6, 7 units. And for my height here, I have 1, 2, 3 units. And again, I'm trying to figure out how much space is inside. Well, fortunately, I have a nice piece of graph paper here. I can count the number of units. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is 21 square units on the inside of this rectangle. And looking at this, I would think to myself, well, I had a base of 7 and a height of 3. I must have multiplied 7 by 3 in order to get those 21 square units. And in fact, that's what we would do for any rectangle that we have. In order to find the area of a rectangle, the area is going to equal the base times the height. If I know the base of the measurement and of the rectangle and the height, I can simply multiply those values together. And so in this example, looking at this rectangle, well, I can see that this is 7 centimeters in length here, which means down here it's also 7 centimeters. So I know that the base is 7 centimeters. The height right here is 2 8/10 centimeters. So I'm just going to substitute those values into my equation. A equals the base of 7 times the height of 2 8/10. And when I go ahead and I multiply those, well, that's going to give me an area of 19 6/10. And now I need the units. I see here that everything's labeled with centimeters, but we need to remember that when we're doing the area, it's going to be the units squared. So in this case, the area of our rectangle is 19 6/10 centimeters squared, or square centimeters. The next shape we're going to look at is a square. Now, a square is very similar to a rectangle. In fact, a square is a rectangle with special qualities. We know that on a square, all 4 sides have the same measurement. And so I know for this square that all 4 sides are 4 centimeters in length. And so since a square really is just a rectangle, our area formula is exactly the same. Area is equal to base times height. And so what we're going to have in this case then, I'm going to substitute in my values. The base and the height are both 4 centimeters. So all I have to do is 4 times 4. That's going to give me 16. And the units, again, are going to be square centimeters, centimeters squared. Our next shape is a parallelogram or a rhombus, a parallelogram or a rhombus. And so I'm going to bring my graph paper back out, and I'm going to try to sketch a parallelogram. Okay. And there is a nice parallelogram. And so in this case, we can see, well, this segment right here is not perpendicular to the base. It does not form a nice right angle like up here it did with our rectangle. We see here that the height and the base are perpendicular. It forms a nice right angle. And so we've got to see what we could do to maybe try to come up with a formula for the area of our parallelogram. And one thing that I notice when I look at this parallelogram is that I could take this part of the parallelogram, okay, and I see I've got this little triangular piece right here. If I were to remove this piece and put it over on the other side, if I put it over here, all right, and let me cover that up. Well, now I think I can see that this really is a rectangle. Okay, and so I know that the formula for this was area equals base times height, and in fact that's what it's going to be for a parallelogram or a rhombus as well. Okay, and so looking at our picture right here, you could imagine that we took this part of our parallelogram and we just attached it down here on this side, and we could envision, okay, that we have ourselves a rectangle. There it is. There's our nice rectangle. So we're going to use the same formula, area equals base times height. And I can see on this parallelogram that the base here is 17 meters, area equals 17 times, well, I need the height. And remember that the height is the value that is perpendicular, forms a nice right angle. That is not this length here or this length here. It's this length that we see right here, which is going to end up being 8 meters. And so when we go ahead and do the multiplication this time, we're going to end up with an area of 136 square meters. The next shape that we're going to look at is a triangle. And if I bring my graph paper back here, what I'm going to do, I'm just going to draw a picture of a rectangle again. Here's a nice rectangle. And again, for this rectangle, we know that the area formula is base times height. Area equals base times height. Well, I want to get the area formula for a triangle. And what I could do to this rectangle, I could draw in this diagonal from here to here. And now I see two triangles inside of this rectangle. This rectangle is made up of two triangles. Well, if I want the area of just one of these triangles, that's going to be half of my rectangle. And so what I'm going to do is I'm going to use the same formula, area equals base times height, but I only want half of that for my triangle. And so that's the formula that we're going to use to find the area of our triangle. Area equals 1/2 base times height. And so we can look at our triangle over here on the right. We can see that the base is 16 meters in length. And the height, again, this value that's perpendicular, I see my right angle symbol there. This height here is going to be 5. And now I can go ahead and do my multiplication. Well, I know half of 16 is 8, and now I have to do 8 times 5, which is going to give me 40 square meters. 40 square meters. The last shape that I need to find the area formula for is a trapezoid. And I've gone ahead and I've drawn a picture of a trapezoid here on my graph paper. I have to try to find the area of this shape here. And what I'm going to end up doing, I want to take this trapezoid and I'm going to flip it upside down, and then I'm going to attach it to this end of this trapezoid here. So 1, 2, 3, I'm going to extend this 1, 2, 3 lengths down here. Okay, 1, 2, 3, 4, 5. I'm going to extend this 1, 2, 3, 4, 5 lengths here. And I'm going to connect these points, and now this looks like a parallelogram. We know the area formula for a parallelogram, area equals base times height. Well, looking at this parallelogram, the base is made up of this value here and this value here. I can call this value base 1. And this length right here, well, that was the top of my original trapezoid, and I can call that base 2. Okay, well, to get the entire length, then, I need to take base 1 and base 2 and add them together. So the area formula, I'm going to have base 1 plus base 2, and I'm going to have to multiply this whole thing by the height. So I'm going to put that in parentheses and multiply it by the height. But that, again, would be for this entire parallelogram. I only want for one of these trapezoids. Well, one trapezoid makes half of this parallelogram. So I'm going to multiply this by 1/2. And this is the formula that we're going to use to find the area of our trapezoid. Area equals 1/2 of base 1 plus base 2, which are the two sides that are parallel to each other, and then multiply that by your height, which is perpendicular to both of those sides. And so substituting here, area equals 1/2 of, my bases are 6 and 20, times my height here, which is 10. Following order of operations, I need to add 6 and 20. That's going to give me 26. And so I have half of 26 times 10. Well, I know half of 26 is 13. And now if I multiply 13 by 10, my area is going to equal 130, and the units are going to be square centimeters, or centimeters squared. Okay, and so those are the formulas that we need to know and memorize in order to find the area of any of these polygons that we talked about here today. Okay, triangles, squares, rectangles, parallelograms, and trapezoids.